Okay, so we're going to talk about web services and specifically, I guess, how they are of interest in a penetration test. But I mean, also, I want to go over a lot of just the fundamentals around web services because there's a lot of gaps there. A lot of people have some gaps in their knowledge, or they're not really sure about some of the terminology. So we're going to go through that as well. So thanks for joining. My name is Jason Gillam. I am a senior security consultant at Secure Ideas. We are a penetration testing and security consulting firm. We also really like to teach a lot of what we do, so we spend some time doing that as well. I have a varied background. A lot of it is with development as well as penetration testing. So that's kind of why web services is something that's a bit of an interest to me. I'm also an open source contributor. I'm the author of Burp's CO2 extension, and I've also had some input into a number of other projects as well. So anyway, let's jump into the web services. First of all, why are we even talking about this? The thing is, web services, I mean, they started off mostly as sort of the stock ticker and or weather sort of web service when they first came out. That was the type of thing that we thought of as a web service, and that has changed over time. So now we're finding in the enterprise, everybody is well, not everybody, but a lot of people are using it as a way to abstract their a lot of their legacy systems. So that's one area where we're finding there's a lot of web services and even new systems. So rather than having just a database sitting out there with data in it and you connect to the database directly, there's the database, but then we'll put web services in front of it to kind of add a layer of abstraction. So that's one area. We're also seeing a lot of web services in the cloud. Just about every API you encounter in the cloud these days is considered a web service. It's it's basically a remote function call done over HTTP. Also in your rich applications, your HTML5 or AJAX stuff, your mobile apps, a lot of those are basically qualify as web services as well. All of the calls they make to the server side. So I'll be talking about those. They're basically everywhere, so there's something that we definitely have to consider. So a little bit of overview of this webcast. It should run about 2 hours. I haven't done this specific webcast before with all of this content. I've presented some of this content in other forums, but not all of this together today. So I'm not 100% sure that it'll be exactly 2 hours, but we'll try to hit that. What we're going to do is first go over some definitions. I want to make sure that everybody has some level of understanding of the web services jargon. Then we'll talk a little bit about architecture, and then we'll jump into probably the areas of interest, which is the testing tools. I will switch over to I have a virtual machine running here with Burp and ZAP on there, and some of the other tools that we'll be looking at, so we can see how they're set up for web services and how you get started with a web service test. I'll also, in the process, I want to also actually show a SOAP web service and an actual RESTful web service that's returning JSON. So you actually be able to see what that looks like. So if you're not sure what that is or haven't seen it before, or maybe you saw it but you're not really sure what it was, then you'll get a better idea there. And then lastly, we'll take a look at some of the vulnerabilities that are specific to web services. Okay, I'm getting a bit of background noise, so I'm going to mute everybody else. Okay. And I'll unmute later on for questions. It's a small enough group that I think we can do that. All right, so let's talk about some web service definitions first. So there are lots of different types of web services, but fortunately we've kind of moved towards two kind of standards, which is SOAP and JSON is sort of the language that we speak with web services, both over HTTP. So SOAP stands for Simple Object Access Protocol. I'll go through these in more detail in a moment. And REST is actually an architectural style. JSON's another language. And then the last one on this list, so non-SOAP or custom XML, there's lots of different things that qualify as a web service, and you can even come up with your own protocol over HTTP that qualifies as a web service. So there is sort of a catch-all of, hey, I've built something completely custom that's not really SOAP and it's not really JSON, it's somewhere in between or somewhere outside of that, and that could still qualify as a web service. I'm not going to go over that sort of thing too much because when you run into those situations, you really have to, I guess, from a testing standpoint, it's a whole lot of exploration at that point. Kind of like looking at a brand new protocol. So SOAP-based web services. We'll take a look at SOAP first. SOAP stands for Simple Object Access Protocol, which, if you've ever looked at a SOAP message, you'll realize that it really is not so simple to look at, at least not for people. One thing that it is simple for, though, is because it's very strict XML, it's very easy for machine code to basically digest it and figure out what it means. So for a program-to-program communication, it is actually quite simple in that sense. Parsing it is pretty straightforward. Any XML parser will be able to handle it. And it comes with sort of a definition around it. We'll take a look at that just in a moment here in the next couple slides. SOAP originated from Microsoft around 1998. It's gone through a couple of revisions since then, but hasn't changed a whole lot. One of the things that I'll point out is if you're depending on where you are, if you're looking more at cloud type stuff, you probably won't see as much in the way of SOAP web services, but where we do find a lot of it is in the enterprise. So that's where it's much more common. Here's an example of a SOAP request. Now in this example, we have a header, which is just a standard HTTP header at the very top, and then below that, you have your blank line, and then you have your the XML request definition itself, and it's broken up into pieces. This is, like I said before, not really that human readable. There's a lot of garbage in and around stuff that you kind of have to see past in order to figure out what this means. But basically, what it is it's an envelope. So there's an envelope that contains a header and a body. And this part of it is kind of actually pretty straightforward. There's a header which it defines what sort of transaction this SOAP request contains, or function call, or whatever you want to call it. And it also may contain, this is optional, the any authentication for the SOAP request. And in the body, it's actually going to have the application payload itself. So that includes basically the parameters, the inputs into that function. And that's pretty much it. So from that aspect, when you look at it this way, it does seem kind of simple. Next thing I'll talk about briefly, and by the way, we're going to go back and we'll take a look at SOAP again later on in even more detail. But for now, let's talk about Web Services Description Language, or commonly referred to as WSDLs. So every SOAP service is defined by a WSDL, and a WSDL itself is an XML description of that service. It talks about what are the inputs, what are the outputs of, and what are all of the functions inside of that service endpoint. So that's basically what the WSDL is. Often, actually not more than often, usually the WSDL is exposed along with the service. So it's done that way to make it easy for applications that are making use of that service to understand what are the functions, inputs, and outputs of the service. This also helps, of course, with testing, because if we run across a WSDL, we already know what sort of language to talk to in order to interact with that service. So. Next thing I'm going to mention briefly is UDDI, or Universal Description Discovery and Integration. I never remember the full phrase. It's UDDI. It's basically a registry for web services. So I haven't run into many cases where UDDI is exposed. It is built into the .NET platform, so you're more likely to run across it with .NET Web Services than others. But it's not a required component for SOAP-based web services either. So where it really comes in handy during a pen test, though, is if you run across a UDDI registry, it's going to tell you where are all the web services. And that becomes pretty handy. It's basically a yellow pages for these things. So that's why that's important to know. In it itself, UDDI is itself a SOAP-based web service, so it's kind of one of those self-describing things, right? Okay. Next term I want to go over is REST, or RESTful, and it's REST-based web services has become quite popular in recent years. It's more of an architectural style, though, not really a specific protocol. But it's still over HTTP. It's defined as a client-server architecture. It's defined as being stateless and having self-descriptive messages. This is the formal description of RESTful web services. What we usually mean when we're talking about REST, though, is that we're leveraging the HTTP methods directly. So, I mean, there's more than these four, but these are the four that are most often associated with REST: get, post, put, and delete. And the response from a RESTful web service, it can be XML, it can be JSON. Both still qualify as RESTful. It should be stateless. So it's not relying on cookie state, for example, of some kind of session. And it's still a client-server architecture. So that's usually what we mean when we say REST. Okay, JSON Web Services. So JSON, JavaScript Object Notation. If you've done any web development, you're probably familiar with this. You've seen it before. Even if you've just done web pen testing but haven't looked directly at web services, you've probably seen some JSON responses and things. It was originally developed as a way to basically serialize JavaScript objects. So you can marshal them into a string that can be sent to services or come back from services and then put back into JavaScript very easily. So that's how it was originally designed. It has kind of evolved a little bit to now it's used as a general alternative to XML. It's used in a lot of places, and I think most of the reason why that is because it's a lot easier. Well, first of all, it's more concise than XML because you don't define tags, and it's also easier for people to read. So when you see a message that's put together using JSON, it's just a lot easier to kind of interpret what it means. It doesn't change the methodology of how we do a web service penetration test, though, whether it's JSON or XML. Really, the only or the biggest difference I would say between the two is when you're working with JSON, you know there's no XML parser on the back end. So that's one less component that you you really can't attack. I guess there is a JSON parser, so there may be some vulnerabilities at some point that come up in certain JSON parsers. I haven't run into any, at least nothing reliable. I've run into a lot more issues with XML parsers, so something to keep in mind. Looking at JSON examples, if you haven't seen it before, if you have seen Python before, this probably looks familiar too. So basically we have, there's 3 examples on this page. You have the first one, which is just a simple object that has 2 key value pairs on it, a name and a tagline on the first one. The second one is that's the format for a list, basically. So we have eggs, milk, bread, and sugar in the list. The last one just shows a simple example of how these can be combined. So let's say you have a web service that's part of a Texas Hold'em program. So you might be returning information about a player and the cards that they hold. And this shows an example of how your key value pairs can also contain lists, which can also contain more key value pairs, and so on and so forth. So the construct of a JSON response can become very complex, but it's still pretty simple in its complexity, right? Follows a very common pattern. So for our purposes, when we're talking about web services, what we really mean is any inter-program interface that goes over HTTP or HTTPS. And what I mean by that is, when I say inter-program, is we have some kind of application code running on the client side and then also on the server side. So that can be either your web server talking to a web service, which is then talking to who knows what on the back end, maybe a database or something. Or it could even be your browser talking to something else, and not the browser directly, but code inside the browser. So usually that's JavaScript, right? So this is where your AJAX comes from. Your AJAX calls out to a web service, gets some information, brings it back, and updates the DOM on the page without actually doing a full page refresh, and that's kind of what gets that dynamic page magic working. The server component is called a provider. It's a web service provider. So it has one or more functions in it, and those that are being provided to consumers. And so the client side of that equation is called a consumer. And again, remember, the consumer can be it can be running on a web server talking to web services, or it could be the consumer could be some JavaScript running inside your browser, or it could even be a mobile application, or a Java applet, for example. So there's lots of examples of what can consume web services, just anything that can basically talk HTTP out. Usually web services are stateless, and I say usually because sometimes they're not stateless. Sometimes they're fully stateful, where they're actually passing some kind of a session, and sometimes they're what I would call sort of semi-stateless, where the state doesn't really matter from one call to another, but we are using some kind of a token or something for authentication purposes, so we keep state in that sense, where an authentication has occurred, and then there's a token or a ticket or something, depending on what type of authentication you're using, which is then resent with each request. So that's I refer to that as sort of semi-stateless, because it's technically keeping some level of state. It's just not really relevant to the application code necessarily. Okay. All right. Next thing we're going to go over is some of the architecture of web services. So first, if we consider that a normal kind of run-of-the-mill sort of web application architecture, this is simplified here. We have a user who's picked up their browser and they're talking to a web server that's doing something. That web server is talking to usually one or more databases on the back end. And so the request goes from the user to the web server, and the web server makes its database requests, and then the response comes back from those, and then the response from the web server goes back to the user. In an example of our web service architecture, usually things get more complex because there's another layer of abstraction in there. So now we have our user talking to their browser. It's talking to a web server, which is, could be running Tomcat or something like that. And it's, rather than talking directly to a database, it's talking to a web service, which is exposing just some function calls. So that's abstracted out. The application running on the web server really doesn't need to know the details of what it's talking to beyond the fact that it's a web service. The web service could be exposing functionality from a mainframe, from an LDAP server, or from a database, or from something else, some other legacy system. It can really be anything. You can expose anything in a web service, or it might not talk to anything at all. The web service could contain all of its own logic. So part of the trick of doing a good web services penetration test is trying to figure out what's really behind that and what attack payloads make the most sense against that web service. So, another one to consider here is we mentioned this one before. You have your browser's running some kind of AJAX application, or maybe it's a JAP applet or something like that. And it's talking to a web server, but then it's also talking to some web services in other places as well, or maybe even on the same web server. And then you have, of course, your I couldn't really come up with a good picture for a mobile device. But basically, your mobile applications will often use basically talk in terms of web services, and sometimes they exclusively use web services. So what we know about web services is that the architectures of these things varies tremendously. Each situation is different. Really all it is, it's some way of adding a layer of abstraction so that if you think of it in terms of remote procedure calls, that's kind of what we're doing. Instead of having to, and all applications that are involved in a web service having to understand what is, variety of technologies behind them, they just all basically speak the same language. They speak this SOAP or JSON-based language to their backends, and that's how they get to the functionality and the data that they need. One of the problems, of course, looking at this from a pen testing standpoint, is this makes a big difference on the overall complexity of what's going on. We see that from even both on like simple applications that are maybe they seem simple at first anyway, and then they're talking to multiple web services that are talking to legacy systems, and maybe pulling together a bunch of different data from various different disparate systems, and then combining that into different views. For example, dashboards, or maybe performing calculations and maybe sending stuff back. They can do just about anything you can come up with there. But then also we see it on the JavaScript side. So you have these rich internet applications that it's not like you press a button on a screen and there's one round trip, and then it refreshes the page, and then you're on the next page. It's these types of applications become a lot more complex, where they're actually making many different calls, pulling different information. Depending on the results of one web service call, it may make another one, and so you end up with some fairly complex applications running inside the browser. Just take a look at some of what's in Google. I mean, look at everything that's inside of Gmail or Google Apps, and how complex those systems have to be, and how many calls they make. It's quite phenomenal what you end up with. Okay, so I'm going to spend a little bit of time now talking about testing the web services. I'm going over the next part here. So first of all, one thing that's worth we'll take a little bit of time talking about here is it depends on what type of test you're doing, exactly how you're going to approach it. And that's why we have these boxes on here, right? So you have your black box test. In your black box test, of course, as a pen tester, you're given very little information about what you're testing. If you're lucky during a black box test, you encounter a UDDI registry. Remember I mentioned that earlier? And with the UDDI registry, of course, you have basically a yellow pages of web services, and then you can just start hitting them and seeing what you get. Then you have your white box or crystal box and your gray box. And in both of those cases, you'd be working with a either some kind of IT manager or development team who's most likely going to at least point you to the WSDLs. And that's really all you should need in order to get a definition of the web services. If you can, let's say you're working in an organization, you're trying to support a dev team by doing some testing on web services, especially if they have complex web services. It's often even better to not just work with the WSDL, but if you can get a sample working request with all of the parameters that filled in the way they're needed, that's really, really helpful to get that right up front from the dev team, because the tools, once they digest that WSDL, they're really going to, basically you're going to have a list of empty fields that you have to fill in with some kind of data, and if you don't know what to put in those fields in order to make the request actually work, it makes it it can make it hard to test. It really depends on how complex the functions are. So that's one suggestion I have is if you're working with a dev team and you can get sample working requests, definitely do that. Okay, tools. Automated tools for web service testing. There are some, and I actually have a list of them on the next page that you can use, but basically there are some issues with automation. I mean, there's issues with automation with web pen testing as well by itself. There seems to be at least as many issues with web services testing. So one of the problems is web services themselves. You're basically, whenever you define a web service, you're basically creating an API to access some kind of functionality on the back end, right? So when you point a tool at it, you're relying on that tool to interpret exactly what that API is, and depending on the context, the tool may have trouble understanding exactly what's meant by the web service. So it can do things like try cross-site scripting vectors in every single parameter and just see what happens, basically. So there's some things that the tools may be able to do, but they do have some trouble understanding, especially logical issues. They don't run any JavaScript, so if you have, I shouldn't say none of them do. Most of the automated tools out there for web services that I've run into, they don't do JavaScript, basically. So there's limitations there. If you're talking about a RESTful or JSON based web service, it's not going to be a whole lot of help. Most of the I would say most of the kind of the more common vulnerabilities that we run into with web services are not even discoverable through automation. They're things that are actually not that hard to figure out manually and not overly time consuming. So it's that's another case sort of running against the automation. And the biggest problem that I've run into is most of the automated tools are somewhat aged. They haven't been maintained over into recent years. So let's take a look at some of what's out there. There's a cool tool called WS Fuzzer, and this one's I think it's the most recent one I have on here with the exception of SOAP UI. And it's actually pretty good. Command line tool, and it'll spit out some results that you can basically walk through and check for false positives and I will occasionally use this. It is meant for SOAP-based web services. So again, if it's a JSON-based web service, WS Fuzzer is not going to be a whole lot of help. Web Scarab which is an old intercepting proxy. It does have a web services tab. I don't know of anyone who actually still uses Web Scarab, so I don't know. That may be of limited value there as well. WS Digger, it's been around for a long time. I haven't seen any releases since 2005. Maybe I missed one, but it's another case of older tools. WS Scanner as well. I mean, some of these, look at 2000. That's over 10 years old at this point. So it doesn't mean it doesn't work, but it really hasn't been maintained either. So really, the best tool there for automate in terms of automated tools that has been kept up to date is SOAP UI's security test suite. The problem with that one is that it's not cheap. That one actually does have a price tag on it, and I've used it and I've had very, very limited results. It's again kind of going back to what I was saying on the previous slide. There are enough issues with trying to automate web service testing that, in my experience, you're best off. Most of that automation you can actually do through your intercepting proxy instead. And I'm going to go through that in a moment. So my conclusion, and again, you don't have to take my word for it, but you can try these out, see if they work, see if you get any results from them. But I wouldn't rely on them. I really think that, at least based on my experience, you're going to find more of your vulnerabilities through your manual testing with web services than you will through your automated testing. So speaking of manual, how do we do that? So what we're going to do is we're going to use our intercepting proxy. And right now, there's two main ones out there that, or at least that I'm aware of, that are kept up to date and regularly get updates and do a really good job. And that's Burp, Portsfigur's Burp suite, and Z-Attack proxy from OWASP. So both of these do a pretty good job, and they do have the ability to, once you get one request in there, you can then use that request as basically a template and resubmit it and make changes and submit it again. So they both have that capability in there. So what we'll want to do is generate some kind of test traffic. So get a valid request response, and then make use of that to then probe and test the application. So we'll capture that inside of our intercepting proxy, and then we'll resend it in various different ways until we find what we're looking for. So generating that test traffic, there's a few ways of doing that. Like I said before, if you can get sample requests from your development team, that's very helpful. Maybe you just need to copy and paste it directly into Burp, and you don't even have to worry about any other tools. If not, then you can use a tool to generate some test traffic, and I'll get into some examples there. And you can maybe use HTML forms. I've seen some people do this. I usually don't, because I find it faster to either start with a sample request or use one of the tools that are available out there to generate some test traffic. So the main tool that we're going to use is the same tool that we're going to use for web application pen test. You're going to use your intercepting proxy. Okay, so basically what an intercepting proxy is, if you're not familiar with it, is it's a tool that you use to intercept your HTTP requests between your browser and your server. And you can then make changes to that request or replay that request multiple times. You can manipulate it. Nice thing about it is it also saves all of your history, so you can go back and figure out, when I made this type of request, it had a certain type of response versus another type of request having a different type of response, and you can kind of study that the differences as you go through them. So every little change you make to that request, you can see how that change impacts the response. Okay, there are, like I said, two different intercepting proxies that are, there's more than two out there. There's a bunch of older ones, and then there are some, like Fiddler 2, for example, is still maintained. Fiddler 2 is probably more popular in the development circles than in web pen testing. But the two that are probably the most commonly used in web pen testing are the two that are platform independent. So we have ZAP proxy, and it's Java based. It has tons and tons of plugins available. It's really well maintained. It's based on if you've ever heard of Paros proxy. That's kind of the how ZAP proxy got started. It was off that. I don't know if any of the original Paros proxies code is actually still there. I think a lot of it's been rewritten or replaced. But this is ZAP is a pretty good tool, and of course it's free. It's fully open source and free. Burp Suite is Portswigger's product. They have and it's equivalent, I guess, to ZAP proxy. I actually like it better. There's certain aspects of the interface that I find a little bit more intuitive, and maybe that's partially because I use it more often. I also like the fuzzer on it, intruder, better than the one that's in ZAP. It has it also has extensions. It has the BAP store on there, so you can download and install extensions on there. It is a commercial tool, so there is a free version which is somewhat disabled. For web services, most of it you can probably get away with just using the free version. But the price tag on the professional version is worth it if this is something that you're doing on a regular basis. Last I checked, I think it was around $300 per year. So that's not too bad for a tool that you're using all the time. And yeah, one point I will make with Burp, I see it going in the chat, is talking about how much memory it takes. And you might find the same problem with ZAP too. I'm not sure, but because they're potentially collecting a lot of requests and responses, they are memory hogs. So you want to give it additional RAM if you can. There's startup options in order to increase the RAM. Okay, so we have our intercepting proxy. We need some way of kind of figuring out what's, when we look at a WSDL, what sort of functions are available and potentially sending some of those. So there are a number of different tools that can do this. Let's just see. When we put those two together, we have kind of the happy cat scenario here, right? So we have our WSDL tool that's able to go out there and get the WSDL definition, create a function call, send it off, and then your intercepting proxy captures it, and then so you have something you can use in your intercepting proxy. One of the main tools for this is SOAP UI. We'll take a look at that in just a second. So it's a commercial tool. There's a free version of this as well. The pro version actually includes the ability to generate security test suites. The test suites that it generates, and this is just in my opinion, are not overly complex. You can replicate that functionality without having to buy SOAP UI. You can do a lot of the same tests directly inside of Burp or ZAP. So if you already have SOAP UI for development purposes, for example, then it may be worth using it for some of the security test suite generation. If you don't, it's probably only worth buying a license, because I don't remember what the cost of a SOAP UI license is, but it's not cheap. It's not your $300. If I remember correctly, it's significantly more than that. So unless you're doing a lot of web services development, or if you're testing them every day, it may not be worth the cost of the pro license just for that test suite. Okay. Another one is, and this is just one example here. There are Burp extensions, and I honestly don't know if there's a ZAP extension, but it would not surprise me if there was, for digesting WSDLs as well and generating some sample requests. So this is one example called Whistler. If you look in the BAP store, I can't remember if Whistler is listed in there right now, but I know that there's at least one WSDL digester in there. I just don't remember what it's called. Another option, and this is probably becoming my favorite for SOAP-based, is to use SOA client. I use Firefox as my primary browser for doing penetration tests anyway, because of the plugins that are available to it. And SOA client is a plugin for Firefox. It does a pretty decent job most of the time of digesting the WSDL and generating some sample requests. So this is what I'll usually try first, and if this doesn't work, then I will fall back to SOAP UI. SOAP UI is good for the reason that it's always kept up to date. So it's like the primary tool for SOAP-based development. So software developers use it a lot. So it's very well maintained, whereas SOA client maybe not so well maintained. I don't know if it's been updated to the latest version of SOAP that's out there, but it still does a pretty good job most of the time. And the nice thing about this is you're actually generating traffic from your browser just like you normally would during a web pen test. So some of the challenges with SOAP UI don't exist. And actually, I'll go ahead and mention that right now. So one of the main challenges we have with SOAP UI that's come up in more recent versions, it didn't used to be an issue, is that if your web service is only exposed over HTTPS, it's difficult to get SOAP UI to actually be able to trust your Proxies certificate. So that becomes a problem where SOAP UI won't actually read, won't even read the WSDL if it's over HTTPS, because it doesn't trust the connection that you're giving it through your proxy. So that can be a bit of an issue. Okay, the next section I have is on web service vulnerabilities, but before I do that, I'm going to jump over to my VM here and just kind of demonstrate some of the web services that we've talked about in some of these tools. I didn't want to jump back and forth too many times because sometimes that causes problems with these webcasts. So hopefully this will work and we can all see what I have here. Okay. So the first thing that I have is a RESTful web service. Okay. The RESTful web service is, in this case here, it's actually returning JSON. If I just, oh, hang on there, I didn't clear it out from before. Okay, so I have a list on here. It has a cat, a dog, and a fish on it. And this particular RESTful web service, all it is basically a list. I can add items to it, I can remove items, I can completely replace the list. So what this looks like, I think I have this one going through Burp. So we can look at, what I'm going to do is I'm going to take that request that I just did, that GET, I'm going to send that to Repeater so we can interact with it. Okay. And when I send the request, I get my response back. Cat, dog, fish. If I want to add to this, okay, so what I'm going to need to do to add something to this is I'm going to have to change the request method to a post. And I'm trying to remember the syntax I had on this one. So maybe I want to add we'll add a mouse to it. Okay. So now we've actually added another item. You can see the response is still coming back as JSON. Okay. We can then also do a, let's see, go back to the GET here. If we wanted to remove something, maybe we want to take the fish out of the list. So I just took my GET here and I'm resubmitting it as a delete. Okay. And we get a response. In this case here, it didn't return anything, but it's still, I mean, we can see right here, if I refresh this one here, we now have a cat, a dog, and a mouse. Okay. If we have, what's another case here? The put. So the put actually works like a post. And I can define a whole new list. So maybe I'll do a cow and a horse. And in this case here, you can see I'm defining it as JSON as well. I'll put a goat in there too. So hopefully this will work. Yeah. So it's basically replaced the list entirely. So all of this is using our HTTP methods. Some of you probably wondered for the longest time why there were more methods than get and post and options, and that's one of the reasons why. So we have an object on the back end that we're able to manipulate through this web service. So that's basically it. So you might be wondering with something like this, can I go back to the post again? Can I add something that's maybe a cross-site script flaw, right? So let's just go ahead and do that. I'll just do alert 1. We'll make it really easy. Okay, and it did add the item on there. See? So you're kind of wondering, okay, well, is that going to work? If I put this up on here, though, all I get is text back. And anybody know why that is? The problem is the content type, exactly, yeah. So the content type is actually coming back as application JSON, and so it's being interpreted as a JSON response by the browser, so it's not going to actually render it as HTML. So just to show what it would be like, let's go ahead and intercept this request. And I'll change the content type on the response. So intercept the response. I'm going to change this to text HTML. Forward that on, and now we can see it actually did. Go ahead and run that. So we have our pop-up box with our number 1 in it. Okay. So yeah, so the important thing to recognize there, though, is the content type, and you'll find that sometimes in web services. People will have JSON-based web services out there, but they're not returning a JSON response type. Maybe they're returning XML or HTML or text HTML instead, just because they're going with some kind of default somewhere and they haven't changed it. So that is something to look out for in your tests. If the response type is not coming back as a application JSON, then you may run into cases where the response can be interpreted by the browser as HTML, which means script will run in it, which means you could have cross-site scripting flaws. And those, well, I'll get into those in a moment. Okay, so that's RESTful. The other one that I'm going to take a quick look at here is, okay, so what do we do with the SOAP-based? So I have a very simple Hello World web service out here, and it has a WSDL. Okay, and so what we're going to do is we'll take a look at a couple of ways that we can generate a request with this. So I'm going to take this WSDL, I'm going to copy it because I'm going to use it somewhere else. Let me go ahead and bring up SOAP UI. If you haven't seen this before, this is what SOAP UI looks like. Basically right-click on projects, new SOAP project, give it a name, and plug in your WSDL. Just realized I forgot to mention something, so I'll go ahead and finish this first. It went ahead and it basically read the WSDL, read that there's exactly one function call in it called hello, and it generated a sample request for us. This is the free version of SOAP UI. If you have the pro version, you'll get additional views here, so you'll get something where it's more like filling out a form, a web form, in order to get your inputs in there. But with the free version, all you get is the raw XML SOAP, and you can put something in there and run it. Now, one thing I've done, and I'm going to go ahead and just put a name in here so we can see what it looks like. So you run that, you get a response back, and you can see the output from the function call is hello JSON. Okay. So I actually have this going through my proxy. Take a look at the proxy history here. So we can see there's my request and response that I just put in there. The way I did that, you can proxy, if I can find it on here, there it is. Under File Preferences, SOAP UI, there's a proxy settings here, and you can just basically point it to Burp, similar to how you would use with Foxy Proxy or just manually setting your proxy in your browser. So you want to make sure that you have your traffic going through there. I think I'll probably circle back on this afterwards because I have some more things I want to talk about. XXEs or XEEs, yeah, external entity expansion, sorry. So let me go back to the presentation. Okay, so we have some idea of what the difference is then between REST and SOAP. SOAP is it's a bunch of XML that gets packaged up, and there's an envelope and a body, and it gets sent over to the server and back. And RESTful, of course, you're usually making use of the methods built into the HTTP protocol: the get, the put, the delete, post, and it's more frequently associated with JSON. You don't have to. I've seen JSON-based web services that are always using get or always using post, and I've seen, and I've sometimes seen them actually make use of the RESTful, the HTTP methods as well. So you kind of run in a bit of both. All right, so let's talk a little bit about the different types of vulnerabilities. We have, I like to break these down into 3 different categories of vulnerabilities when you're looking at web services. One is I break out authentication, and one of the reasons I do that is because I more frequently find issues with authentication on web services than any other category of issue. So, so that's kind of one. It's worth taking some time to focus on that. And the other thing too is you'd be hard pressed to find any kind of automated tool that's going to help you much with testing the authentication. So that's something that you'll look at it and kind of figure out if there's an issue with it. The next category is I would call it classic. It's basically your classic web vulnerabilities. We're talking about our OWASP top 10 and how those are applied to web services. And then the third category is service-based vulnerabilities. So this is any vulnerabilities that are not part of your traditional web vulnerabilities, but they fall into category, for example, attacking the parser itself in SOAP-based. Okay, so let's talk about authentication first. The number one question you want to ask is there any authentication? Very, very often, especially on internal-based web services, we find cases where we have a web service that's running critical functions or returning critical data that doesn't have any authentication on it. And it's all the usual excuses. It's internal, or you'd have to find it first. But I've even run into cases where someone has gone through the trouble of using best practices to protect the access to a database. So they've changed the SA password and username and are they rotating passwords regularly on that, and then they put a web service in front of it, and the web service basically exposes all the same data that's in the database, but the web service itself doesn't have any authentication on it. So basically, they've used the web service to effectively drill a hole through their security. So this is a pretty common issue. Basically, you need to ask yourself, and developers should be doing this too, if the service returns any sensitive data or performs any kind of critical functions or reacts with resources that would normally require authentication, like a database, then authentication is probably required. So and it's every single call needs to be authenticated. So when you have those JSON-based HTML5 type applications that are making numerous calls back to the server, each one of those calls should be an authenticated call. You need to make sure that the person actually making the request is identified and authorized to make that request. Authentication can take on many different forms inside of web services. It can be handled by the web server itself, whatever web server's hosting the web service. So that's where you might find basic or digest. If that's the case, one of the things that you probably ask yourself is sort of the same thing as when you're doing a web pen test, right? Is can you brute force it? So if it's using basic, for example, can you just make many different requests across a dictionary and find your way in? Because usually basic authentication doesn't have any way to slow you down. The thing is, unlike users, often if this is a server application that's talking to a web service, you probably don't want that service account to get locked out, like you would want a user to get locked out if they tried too many times to log in. So the solution, of course, there is to make sure that it's being properly monitored. So if you're getting, and possibly also have filtering based on where the request is coming from. If you're using a service account, you should be expecting it's only going to originate from certain servers. So that's something to look out for. If you're monitoring your logs and you're finding that, hey, we're getting a bunch of requests from somewhere else outside of that, then you might want to pay attention to that. Another place that you'll find authentication is actually embedded directly inside the web service. So I mentioned before the SOAP envelope can contain your authentication as well. The one thing, though, I've seen sometimes on this one is that you run into cases where username harvesting is possible. So username harvesting, usually you think of it on a web page, is when you put in a user that doesn't exist in the system, the response comes back and says, hey, yeah, sorry, we couldn't find that user. Instead of saying, the username password combination is invalid or something along those lines. So if it gives you back information that can help you determine whether or not the user exists in the system, then you may have a username harvesting flaw in there. And that the same is true for web services that perform authentication. Okay, another possibility is that you may have some kind of delegated authentication. What I mean by that is maybe the authentication isn't directly on the the web server itself, but it could be happening somewhere further down the line as part of the application code. Maybe it's authenticating against an LDAP server or a database. One thing I want to point out is that the if you do have a database or LDAP and authentication, make sure you at least check to see if wildcards work. So you may be able to authenticate using probably not with the password, but you may be able to at least get past a username by using a wildcard. So that's something else to look for too, and especially in conjunction with username harvesting. So instead of looking for a name like, let's start with the letter A, right? Instead of looking for Andrew, maybe you're going to look for A star, and if that tells you that, hey, yeah, this user exists, then you can try, AB star and then AC star, so on and so forth. So make sure you're looking for that sort of thing when you're at least test to see if it works. I have run into cases where this works, and it's in LDAP in particular, because it's kind of hard to do proper input validation with LDAP. Okay, next is you want to also look to see if you have any errors. A lot of this is the same sort of stuff that we run into with web applications, right? So are you getting LDAP errors or SQL errors? SQL injection possible through the authentication mechanism? If someone has implemented a lockout, then could you potentially DOS the service just by locking out the service account? So that's something else to look into. That could be a pretty serious problem, right? And some of the other usual culprits also. If it's a custom solution, some kind of custom authentication on the back end, developers should know by now that that it's best not to roll your own, but some of them still do it. Some of them think they're smart enough to do it, and sometimes they're right and sometimes they're not. So you want to then check to see if all the same usual stuff is there. Look for username harvesting. Look for predictable tokens if they're using some kind of token for state. And the other thing to check is does the authentication even work? And this is also based on experience. I've run into cases where if you put in the wrong username and password, it comes back and says it failed. If you put in no username and password, like just take that part, let's say it's part of the envelope, if you just remove it entirely, then it actually lets the function actually go through. So it's another thing you'll want to test. And all of this you can test in your intercepting proxy, right? You just send the request, put it into Burp repeater or in ZAP's request repeater, and just send it and make those particular changes to it, and then send it again. Certificates. So client-side certificates, at least in my experience, they're one of the hardest for us to attack. It's usually long enough that you're not going to be able to brute force it any sense. And if they're rotated regularly enough, then the odds of stumbling across a way in through a certificate without actually stealing the certificate somewhere along the way are extremely slim. So from the developer side, if you're developing web services that need to be secured, using client-side certificates as a form of authentication is probably a good idea. But I do have that caveat on there. You still need to monitor your logs, though. So if somebody does manage to steal a certificate, then you're going to want to know about traffic coming from other places. Okay. Next, we're going to run through some of the what I call the classic web app type of web service vulnerabilities. So mostly what we're looking at here is the OWASP top 10. I've put that on this list. If you're not familiar with the OWASP top 10 and you're getting into penetration testing, or even just looking for a hive, like an overview of web pen testing, then that's something you should really take a close look at. And actually the whole OWASP.org website's worth looking at if that's the case. So considering classic web applications, it's all about context. It depends on what's happening on the front end and what's happening on the back end, and actually the architecture of the web service as well. So there's many different variations. There are times where, just because of the way the web service works, certain types of flaws just are extremely unlikely to occur. And then there's others where the flaw is much more likely. And these are the types of things where, I mean, you can throw an automated scanner at it, but you may end up getting a whole ton of false positives or false negatives with that. My experience is better to use a bit of human deduction, I guess, to figure out, what is the overall context of the web service, and from there you can try to work out which vulnerabilities are most likely to occur. So first, let's take a look at what I refer to as the producer web service vulnerabilities. So remember, the service producer that's basically the server side of the equation. So these are the things the types of vulnerabilities that will impact the server, or the producer of the web service itself. So first of all, we'll take a look at, are there access level controls that are necessary? We talked about authentication. We also need to consider authorization. Sometimes there are web services where it makes sense to have multiple different roles, and just doing authentication by itself is not enough. Sometimes it needs to take a step further. Maybe there's some kind of it could either be sort of a like vertical roles where you have an administrative type of function, or it could be like horizontal roles where you have a user with bank accounts, for example. You don't want one user to be able to access some other user's bank account. Just because they're authenticated doesn't mean that they're authorized to access all of the information they've requested or perform actions on that. So all of that needs to be tested. And you think about that, that's not really something that your automated test is going to be able to cover. That's you really have to, kind of takes a person to figure out what are the roles that are necessary and how could they cross those boundaries. So those are the types of things that you want to test there. The next one is injection attacks, and these really depend. I mean, it really depends on what's on the back end. What's behind that web service? That tells you, what sort of injection attacks are possible. There's not going to be an LDAP injection if there's no LDAP server behind there. That's kind of the way it goes. So this is something where it's really helpful to reduce the scope of what you need to test if you're doing a gray or white box test and you can get that information. If you're doing a black box test, you probably should just test everything, or as much as you have time to test. Try to look for some hints about what's going on. If you get any kind of error messages, sometimes those can be helpful. They'll let you know if it's a database somewhere behind there. Also look for any cases of reflection. So this becomes important for other reasons once we get into XML parsers as well. But by that, what I mean is there ever an instance where you have an input that either on this response or any other response it comes back to you? That's potentially useful in injection attacks. So the type of these are just some examples here, probably some of the most common ones. If you figure out the back end is a relational database, then you're going to look for SQL injection attacks. If it's an LDAP server, you look for LDAP. If it's any kind of interaction with an operating system, maybe it's running a mail command or something like that, then you're going to look for a command injection. And if it's manipulating XML, then you're going to try XPath injection there. So those are all different types of injection attacks. Like I said, it depends on what's on the back end, what's going to work, and what you need to try. In all of these cases, if you look through your payload lists for ZAP or Burp, or look at other payload lists, like take FuzzDB for example, you're going to find payload lists for these types of injections. So you don't have to rely on a tool like SOAP UI Pro to build your security test suite for you and come up with a payload list. There's already payload lists out there, and you can just set up your payload positions inside of Burp, for example, Burp Intruder, and go ahead and run those against the web service and see what comes back. So. Okay. The next vulnerability is an information disclosure. This one comes up quite often. You have information that's coming back in the web service that probably shouldn't. Again, if your authorization, your authentication are in place properly, then for the actual data that's supposed to come back, then you're okay there. But what we're talking about here are things like, especially if you have an XPath injection flaw. So let's say there's some manipulation of the DOM on the back end, or let's say we're talking about a database or LDAP server. Can you use that web service to actually return larger data sets or different data sets than it's intended to? And this is what you're going to look at wildcards. You're going to look at XPath expressions. Maybe you can get to a different tree in an XML DOM on the back end and return some other information. And also you want to look at any error messages that come back. On a web application, we at least well-designed applications will typically return fairly generic error messages. That's what we keep telling everyone to do. And that's also more user-friendly too, because most of your users don't want to see a bunch of gobbledygook on the screen that they don't understand. So having a friendly error message on there is what is better from a user experience standpoint. For web services, though, we tend to be a little less cautious with that. Returning a more verbose error message is a bit more common, and because it's not exposed directly onto the user interface. So those types of flaws are a little bit more common there, where you have maybe a stack trace or some more details about what exactly went wrong on a particular service call. So watch out for that sort of information as well. Another one that's again pretty common in web services is when there's direct references to objects. Part of this is because of the way web services tend to be stateless. I think that's part of the reason that drives this issue. So being able to actually reference an object by an identifier of some type and have an operation perform on that identifier without necessarily all of the necessary enclosing context. Who's actually submitting the request? Do they have permission to? That sort of thing sometimes goes missing. So if you find cases where you have some kind of identifiers being passed in and information is coming back, is that something that's sequential? Is that something that you can iterate over? We've run into that on web services, and it's pretty common with. I have an example on here actually that's pretty common, where you have some kind of like a client or employee ID. Those do tend to be sequential numbers when they're out there. So if it's something you can iterate over easily, then you may be able to pull back large amounts of data through the web service that you normally wouldn't be able to get to so easily. So that is another thing to kind of look at. And again, this is another thing, just like most of what we've gone through so far, that your automated scanner is probably not going to really take a look at or notice. Okay, so the next flaw we're going to look at, this is the last that I have on the producer side, is business logic flaws. These are probably, I would say they're a little less common in web services that are truly stateless. Okay, so if the web service is actually stateless, then and it's designed properly, then it shouldn't allow for a logic flaw to occur. Now, logic flaw, an example of that is the typical example, of course, is the shopping cart, where you have a a certain sequence of actions that are supposed to occur in a certain order, right? You add things to the cart, you total up the cart, you go through the checkout and pay for it. And then your items get shipped. And if you're able to rearrange that order somehow, then you may be able to, total up the cart, then add things to it, and then ship, and or pay for it and ship. So if you're able to rearrange that order somehow, you may be able to get some free stuff, right? So that's what we're talking about when that's a classic example, I guess, of a logic flaw. But they're all over the place. Now, you got to think about this in terms of web services, though. If you have an application that's relying on web services for each of those calls, it has to have some way of keeping track of whether or not all of the steps have been followed in the right order. One way that they may do that is through some kind of a nonce. But it's definitely something that you'll want to see if you can abuse. There are cases where you have a web application and it's talking web services to a back end, and the back end just assumes that the front end knows what it's doing and that it's going to send everything in the right order. So it's the exact same type of problem you run into with web applications. You can run into it with web service-based apps as well. Okay, on the consumer side. So we already tried playing around with JSON, and we noticed that when I had my JSON example up there, that because the content type coming back was actually JSON, the browser interpreted that in a way that we couldn't actually use it for cross-site scripting. So one of the things you're going to look for is, what is the content type that's coming back? Is it what it's supposed to be? If it isn't, then you may be able, anywhere where you can find some reflection, if there's not any sort of strict schema checking, XML schema checking in place, or input validation. Output encoding is kind of rare to find, especially in SOAP-based web services. So there are opportunities potentially to have a cross-site scripting flaw against a web service. And if you have a cross-site scripting flaw against that web service, of course, it might not look like anything to the user. So it's going to happen a little differently, I guess, than it would with a web application, just in the sense that they're not going to land on a page that has an actual page that has a cross-site scripting, but they'll still be sending a request that has a response with cross-site scripting flaw in it. So there's also the possibility of being able to use a web service to inject a persistent cross-site scripting flaw. Let me actually go on to the next page here. Yeah. So you have your reflected, like I said, that's reflected is when you put the payload in and you get a response back, and that response actually contains one of your inputs from your request. And if that input has a malicious payload on there with cross-site scripting, then that should pop up on the screen. That's where we get our alert pop-up box or beef hook or whatever it is that we're doing for cross-site scripting. So it is possible to do that inside of a web service. It may be possible. It's something to check. The other thing to consider too is it may also lead to DOM-based cross-site scripting attacks. So I don't have a bucket for DOM-based on here because it's not a user interface, so there's no DOM to manipulate directly, but indirectly it is possible sometimes for an XML-based or a JSON-based, either one, web service to result in a DOM-based cross-site scripting attack. So if there's a way that you can have an input on a page somewhere that gets sent in maybe an AJAX request, for example, and then comes back and from that request gets put into an object somewhere that then gets put into the DOM, you kind of see it ends up being fairly complex, which is why we don't really have, or we haven't up until fairly recently, had very good ways of detecting DOM-based cross-site scripting. It can follow a very complex route before it actually ends up on the page and shows up and executes, but there are possibilities for that happening, so it's something you definitely want to look at. Also stored. So stored or persistent or whatever you want to call it. Basically, you have your cross-site scripting where a payload ends up stored in a database or LDAP server or some other kind of back-end system, and then at some later point in time it ends up showing up on a page. So you may find that maybe you can't inject your cross-site scripting flaw, your persistent cross-site scripting flaw, through a web application, but maybe you can inject it directly through the web service, and then later on at some point in time when someone's browsing something that pulls information back from the same data source, it ends up showing up on a page. So that's kind of what you want to do, is kind of trace your inputs from your web service. Is when do they show up downstream, and is there a possibility for you to put in some like a cross-site scripting flaw. Okay, the other consumer side vulnerability that I'd like to talk about is cross-site request forgery. And this one here it's actually another very common one inside of services, especially where we have these like HTML5, AJAX-y type applications, because it's one of those things. We see cross-site request forgery most often. We see like the protections against cross-site request forgery on forms, right? We have the token that's put on the form that has some kind of random value that then gets checked when the form is submitted, and if it doesn't match, then we reject that request. That's the common defense against cross-site request forgery attacks. One of the most common ones, but we run into cases where the web services don't have the same protections on them. So we have to look, and this is, there's still requests. They're still going over HTTP. It's still possible often to force someone who's browsing a site that the attacker controls to submit a request to a service backend, and if that's the case and the authentication is already provided through, for example, a cookie, then it may be possible for the it may be possible for them to actually execute the request. So, like I said, this is cross-site request forgery flaws within web services are fairly common. So that is something that you definitely want to look at, and it can be XML based or JSON based. It's sometimes complex to put one together, but it's still something that you want to check. So look for cases where are there cross-site request forgery tokens in place. If there aren't, then what you want to do is basically do some testing for it. So see if you can force someone who's off-site to use an image tag or an iframe or any of the other CSRF techniques to see if you can get a request to actually go and submit a web service request on behalf of that user. So, all right. Web service parser vulnerabilities. Okay, this category really is exclusively for XML. So usually we're talking SOAP. Doesn't have to be, but it usually is. And what we're looking to do here is we want to see if basically a lot of XML parsers, actually I think all of them, will still support DTDs. I don't know if anyone remembers document type definitions. So they can be in line. You can actually specify local DTDs. They're supported by just about all XML parsers. They can be disabled. Some of them are disabled by default now. So really what you want to do is when you're testing, you'll want to see if you can add to the request a DTD on there and determine whether or not it's getting processed. If it is getting processed by the parser, then there may be some opportunities for some other types of attacks directly against the XML parser. The first of these is called an XML external entity. And what we're doing here, if you see in here, so if you're familiar with entities in HTML, basically, you have your ampersand, GT, semicolon is greater than sign. That's basically, we're doing the exact same thing, except we're defining them inside of the doc type definition. So to do that, what we do is we have that entity tag. Let's see if I can point to it on here. So we have an entity tag, and then the value, actually, let me go back to the previous one. I think that had it better on there. So in this one here, we have entity bar is equal to hello world. Okay. That can be replaced with a system entity. So there's a system keyword on here, and then you can reference, in this case here, we're referencing a local file, etc password, which if it was actually expanding that, then it would go out to the file etc password and it would insert that on there. So if we have a case where we put whatever's inside of foo here, if we have a case where we can put that into the request and then the same thing gets reflected in the response, what this will do is it'll actually reflect the contents of this file. So it's a way to actually look at files on the file system through the web service. You can also look at remote files, so you can basically proxy web requests through there. It's possible to return a directory listing if this flaw is on there. And the other thing to consider is it's not just files. Files is what I use in that example, but you can pull in data from other places. You can make use of FTP, mail to. There are some implementations that actually support jar, and some older implementations, I don't know of any current ones, that will even support Gopher. And I don't know a whole lot about Gopher. It's a blast from the past at this point, but there I don't know. There could be some other vulnerabilities involved with Gopher itself, because it is such an old protocol. It's not really used anymore. But it may be possible to get some additional information through that you wouldn't normally be able to get to. So that's one. The other one that's pretty common to talk about is something called an XML bomb, or the billion laughs vulnerability. This is a denial of service vulnerability, and I have an example here on the screen. It's might be, if you haven't seen this before, it's probably a little bit baffling to look at. But basically, what you do is you consider that you define one entity. In this case, is LOL. It's defined as this whole string of LOLs. And then LOL2 is defined as the entities LOL from this first entity here over and over again. So what's going to happen is when the parser reads this, it's going to expand each one of these LOL2s into an LOL line, which contains 10 LOLs on there. So it'll expand those. And then LOL3 is going to expand each of the LOL2s, which is going to expand LOL. So by the time we get down to LOL4 on here, we have a very large number of LOLs. Not quite a billion yet on this case here. This is a smaller example, but using the same pattern, you can take a fairly small amount of input and generate a memory-consuming process basically through the XML parser. So it just eats up all the RAM trying to expand all of these entities, and basically blows up on the back end. So it's a denial of service type of attack. The solution to both of these issues, the best solution is to basically turn off inline doc types. So your modern XML parsers will actually allow you to do this. There'll be some kind of configuration setting on each one to turn this off, because there's really not a need for it. So if you're on the development side, you're trying to figure out, well, how do I prevent this from happening? That's the best way. If you absolutely need to have the inline doc types, then look for configuration settings that limit how much expansion occurs. So maybe you want to, and again, it really depends on the parser which settings are available. But if you can limit to not allow for the system entities, so you can't actually reference a URL, then or a local file, then that's definitely something you'll want to turn off. And you can also, again, depending on the parser, you should also be able to limit how many times will it do an expansion. So if you can reduce it, maybe it can only expand twice or 3 times or something like that, then you can reduce the impact of the XML bomb type of attack. So hopefully that makes sense to everybody. Okay, on the platform itself, sometimes there's information disclosure as well. There are test pages. You'll find cases where we run into this all the time. The web service itself, there's test pages for running tests against the web service. So that can be useful, especially, I mean, it's useful to developers or whoever's trying to debug a web service. It's also useful to attackers. You also run into cases where there's status pages out there. Access has something called Happy Access, which is installed by default. So if you do a vanilla install, in fact, I have one I can show you. Let me go ahead and do that. Okay, so I have a Tomcat instance here. It's just a vanilla Tomcat instance, and I installed Access 2 on there. It's also vanilla. It has, by default, it has this get version service on there that you can play around with. But then there's this validate, which is the happy access. See it up here in the URL bar. And we'll just take a look at some of the information that's on there. It tells you which version of the application server, the platform that it's on. It gives you information, you know, exactly which version of Java I have running on here, where files are located. Just kind of scroll through some of the other information that's on there. Your class paths are on there. So there's a you know, a fair bit of information on here that might be able to help in further attacks, or at least some fingerprinting. And really, once you have everything up and running properly from a development standpoint, this is a file that you probably want to take down. You can always put it back up there if you need to debug something later on. But you want to probably get rid of that. That just gives away more information that's necessary. So you have an information disclosure on that one. Okay. Actually, while I'm here, let me look at one more thing too. So one thing I wanted to go over a little bit was when you're testing SOAP, you know, some of the other ways that you can get the SOAP message into your intercepting proxy. If you don't want to work with SOAP UI or you know, looking for alternatives, one option is there's a Firefox plugin I mentioned earlier called SOA client. And so the way this works is you basically go to Access Web Services. If you have a UDDI registry, you can plug that in as well, which is kind of cool, because then it'll just list out all the services for you. But basically, you put your WSDL in, or you can actually, if you have a file, you can upload it right there. And then it pulls apart the WSDL and generates a nice little form for you. Right, so I can put my name in there, I can call invoke. It makes a little harp sound. I don't know if anybody heard that. But then you get to the response right here, which says, I don't know if you can find it on here, but there's the response right there. There's our hello JSON. So if we have this running in here, one thing that we'll want to do is looking at again at the external entities. So let's take a quick look at that and see if we can reproduce some of it in here. So what we'll do is we'll take that request and we'll send it to repeater, or the equivalent inside a ZAP. Okay, so we have here's our request. This has JSON on there in the input. It's always a good idea when you're using repeater inside of Burp to go ahead and send, whenever you send something to repeater, go ahead and just send the first request you get before you make any modifications to it. That gives you a baseline, so you can see how, you know, what happens when you make changes. Okay, so I actually, just to expedite things a little bit, I'll do this here. Okay, so we're going to go ahead and add a doc type and an entity on there. We'll just hopefully this works. Okay, so it still says hello JSON. If we change the name down here to, in this case I have bar as the entity that I've defined. So we'll use ampersand bar semicolon. And what we're doing here is we're testing to see if the inline doc type is actually being processed by the parser, and are we actually getting the entity expanded and reflected back. In this case, we are. So it says hello hacker now because I've defined that in here. If we weren't getting that expanded, then we would probably see ampersand bar semicolon coming back instead, or it might even be the encoded. Since we have special characters in there, they might even come back encoded. So the next step, of course, you would want to check and see if you can do your system stuff on here. I don't think this is going to work in this case here, because I think the expansion is actually turned off in this web service. So, but we still want to try it. If you get this far, you should keep going, right? So we'll go ahead and run that. And yeah, as I thought, it didn't actually work. So it basically choked on this part here and didn't process it. So without that, we're not going to be able to bring back additional files. And most likely it's not going to process any system command in there too. So we're not going to be able to take even remote files off of other URLs or anything like that in this case here. But if we were, then what should happen is right here I would say hello, comma, and then it would have the contents of Etsy password. So if that was actually exploitable in this case, that's what we would see. Okay. Let me go back to my slides. And okay, it looks like that's the end of it. So that's all I have for today. I want to thank everyone for joining. Keep in mind, we do have on the 26th the Tactical Burp Suite webcast. Kevin Johnson and James Jardine are presenting that one. It should be pretty cool. Especially if you're looking at improving your skills with burp, or even if you're new to it, haven't seen it before, it's worthwhile spending a couple hours going over it with these guys. They both have lots and lots of experience with it. We have our webcast catalog is on there as well, so that's where that'll be posted. We will have additional webcasts. We'll be announcing them probably in a while, but right now we're actually focused more on our training week. So if you're looking to maybe get some sun and also get some training in, we have the week of April 6th in Orlando, Florida. We're doing a number of different classes, including a 4-day web pen testing class. We're also doing mobile pen testing, a tactical SecOps course, and we have a couple of others that we're working on bringing in some other instructors as well from outside of Secure Ideas. So it should be quite an event. It should be a lot of fun, and if you get an opportunity to go, it's really worth it, because we'll be around, sticking around, just kind of like at a conference, right? We'll be around after the classes as well. So if you want to keep chatting about something or go over some more ideas on something, we'll actually be there to talk to on that sort of thing. So come see us. We look forward to seeing you. And I guess without further ado, that's the end. So thanks a lot.